So this isn't a long one, it's a very, very short thing, and a little tidbit that given parametric equations, x equals x of t and y is equal to y of t, we can define different vectors. And I know that the idea of a vector is one that many of you are not familiar with, so just underneath this, let's talk about just what a vector is. A vector is simply a direction and a magnitude. It's nothing more than the two of those. It's a direction, which can be defined in magnitude, which can be defined in terms of an angle. So direction can be an angle, and a magnitude, which we can think of as a radius. So really a vector comes down to a coordinate system in polar coordinates. A position vector, when we call that s arrow of t, is defined as the x position, or x of t, and y of t. So this is one way we have to define a vector, and I put little greater thans, kind of, these are grouping symbols off to the end that are simply the greater than, less than symbol. But in this position vector, I'm using a rectangular system to define this position vector. Don't make this more complicated than it has to be. If I put an ordered pair here and I know that that is x of t and y of t, then all I'm saying is that this is the position vector s of t, and it's defined rectangularly by the two places, or by the x and y value. So that is the ordered pair x of t, y of t, and this is what a position vector is. A velocity vector, v of t, and that arrow above indicates that there's a directionality to it, is just the first derivative, s prime of t, y prime of t, as a vector. So again, a velocity vector will have a direction and a magnitude to it as well, but that direction and magnitude can be found by first finding the rectangular coordinates for what that velocity vector would be, and then going back to polar if you need to. The acceleration vector, which we'll call a of t, is the first derivative of velocity, or the second derivative of the position vector, x double prime of t, y double prime of t. And again, same idea, it's a direction and a magnitude. You guys should know that if velocity and acceleration act in the same direction, then we're talking about an object speeding up. And the opposite is true. If they are acting in opposite directions, then the object is slowing down. So a couple of you on an AP problem thought that if velocity is negative, the object's slowing down, and that's not necessarily true. Let's mention this thing called speed. Speed is not velocity, but speed is the absolute value of velocity. So how do you do an absolute value of a two-dimensional quantity? How do you take the absolute value of an ordered pair? Well, the absolute value of an ordered pair is the Pythagorean distance of that vector point to the origin. So let's say that I have a point here that I'm calling x prime of t, y prime of t. This isn't actually a point, this is just a representation of this velocity vector. This is v of t separated into a rectangular coordinate. Well, absolute value is distance from 0. So if I want to figure out what that distance is, I just make a triangle where I have x prime of t, y prime of t, and that distance is the square root of x prime of t squared plus y prime of t squared, and that gives me speed. Last concept, distance traveled. How much distance? Well, distance traveled can be thought of as an accumulation of speed. So if I have a function that is speed, and up above we do have a speed function, then I can do an integral from t sub 0 to t sub 1 of that function. So it's the integral of the square root of x prime of t. I'm going to write that as dx dt squared plus y prime of t, which I'm going to write as dy dt squared dt. And this should actually be familiar to you because this is also arc length. Distance traveled is an arc length. So again, if I just kind of draw an arc from t sub 0 to t sub 1, the accumulation of the speed function is just the distance traveled, and you don't have to memorize anything else because that's just arc length. Finally, a little bit of review from Calc-A, since that was a year ago. Remember that the concept of displacement in a single dimension, which means displacement in a number line, displacement in a single dimension, displacement is the integral of the velocity function, and distance traveled is the integral of the absolute value of the velocity function. Both of those are concepts from Calc-A. So that's all I want to leave you with. You guys have 3 AP problems to get going. Good luck.